This is the video on factoring for section P5 that goes along with day 5 notes. And we have several different types of factoring to review with you here. First of which is the greatest common factor factoring, or what we call GCF. So number one, as we look at each one of the three terms in this polynomial, we see that the coefficients each have a common factor of 6. And the powers of a and b. In terms of a, the lowest power each of them have is an a squared. And the lowest power of the b that they have is a b to the third. So as we look at each expression and we think about dividing that out, the GCF is the 6a squared, b to the third. That has to come out in the front. And what goes inside your parenthesis is what's left as they divide out. So we have left a 4a squared from the first term, and then we have a positive 2a b left in the second one, and finally in the last one we have a minus 3b to the second power. In your polynomials factored, you have a product where your GCF is one factor and the trinomial in the parenthesis is your second factor. Right. In the second example, we've got a little bit different looking expression, and it's not in a factored form because of the plus sign that's between the two expressions. But as we look at both parts of that, in those expressions, they each have a binomial factor of 3x minus y. So that quantity is actually your GCF. That quantity comes out in terms of your first factor, and once that factor is divided out, what you've got remaining is the other factor. So we put in the parentheses the 2x plus 7, and then the sign that is in between there gets included, and then you have the 3x plus 2. So here's your GCF. That's out at the front here, and the remaining factors are left in here, including that signs in between there. All right? And then of course there's some simplifying you can do in this expression, so you go back to rewrite your answer as 3x minus y, and in the second parenthesis you can combine your like terms, 5x and the plus 9. And now your polynomial is in terms of a factored form because you have the parentheses next to each other. There's no longer that plus sign in between, and your answer is in the form of a product, and that's what it means to have a polynomial factored. Now we're going to move into the section where we're considering factoring trinomials. One of the first things you should look at when you do consider factoring any polynomial is that first type that we looked at, which was the GCF. So even though we're calling this a new section, we should examine the polynomials that we're looking at and make sure that each of the three terms do not have any common factors to take out. And then if they don't, we go back to the other consideration of how we're going to factor them. All right. The trinomials we know can be broken down into products of binomials. So as I come here and I look to break down the factoring, the most basic form of trinomial factoring is when our lead coefficient is 1, as we've got here. And that would let us put in the first spots for the factoring as x times x. All right. Your signs are also important to consider. Whenever the last sign is positive, it means that my product of my two last terms, here and here, has either got to be negative times a negative, in here and here, or a positive times a positive. Your middle sign is what tells you what that's going to be. So I'm going to need two negative signs in here to finish up the factoring. And then I pick out the factors of 18. That will give me a combination of negative 9. So since your factors of 18 can be combinations of either 1 times 18, 2 times 9, or 3 times 6. You go with the combination that makes your middle term, that adds up, and you put those in there. So your factoring can always recheck with remultiplying with using your FOIL. So as you do your first times your first, you've got your first term. Your outside product and your inside product make a negative 6x and a minus 3x, gives you the minus 9x, and the last term times the last term gives you the positive 18. Right. Our example in number 4 has values that again do not have any GCF factors, and again the first term in that polynomial has a coefficient of 1, so as we write a combination of factors, we have x times x again. This time, the last term is a negative value, and that means as we multiply our last term times our last term, it has to give a negative product, which also implies that you have to have one positive value and one negative value. And then the last terms that go in each part of the factor have to multiply to give us the negative number. So your combinations, 1 times 24, 2 times 12, 3 times 8, 4 times 6. And of those combinations, you also have to consider the fact that one will be positive and one will be negative, and that combination has to make the positive 2x in the middle. With that considered, that lets you know that you're going to come back and choose the 4 and the 6, where the 6 is the positive value and the 4 is the negative. And you put your numbers in there accordingly. And then again, you can come back and reconsider. You're checking, you're remultiplying. There's your x squared term. Outside product and inside product make a negative 4x and a positive 6x, which gives you the positive 2 in the middle. And then, of course, your last times your last is negative 24. Now we've got the third polynomial to consider in this section, and this time you don't have it quite as easy because that first term is not a 1x squared. So you can do this in two ways. One way that you can do it is what we call the trial and error method. And in that case, you're looking at your two polynomials. And in the first spots here, you can consider factors of 6. So the factors of 6 that we could consider, 1 times 6, 2 times 3. And then, of course, in the last spot, the factors that we consider, we just have combinations of 1 times 5. Your signs can also be helpful because that last sign is a positive and because the middle sign is a negative. The two signs will be the same here. And at least we know the last numbers, the 5s, will only factor one way. They're prime. So I can put those numbers in there and be pretty sure that I don't have any other combinations to try there. And then I can come back to the first numbers and try to decide which choices work. All right? So I can try the 1x in here. I can try the 6x in here. Or I can also consider the combination as if I had a 2x minus 1 and a 3x minus 5. All right. But since we have different numbers in these places, right here, we'd also have to consider what would happen if we had those numbers switched. So if I had 2x minus 5 or 3x minus 1. Of those combinations, you then have to come back and decide where you get the correct middle term, which would be your 13x. So as I come back and check those here, as I check the products here, there is a minus 6x and a minus 5x here. And that's going to give me negative 11x, so I can disregard that product as not working. Now as I come back here, I can check the products here. Here's a negative 10x and a negative 3x, and that one does give me the correct one. So that's my keeper, and I can double check just to be sure here that I've got the right one. As I check the last one, there's minus 2x and minus 15x would have given me negative 17x, and that one's incorrect. Right? So your correct factoring is here. And that's what we call the trial and error method, where you're basically just trying your different combinations of your lead terms to multiply for your first term times your first term, in your combinations of your last term, multiplying your negative 1 times your negative 5. Now, one of the methods that many of you have done has posed this. I'm going to take that one and do it over here because you've got your options of using that method as well. Takes a little bit longer, but some people get very frustrated with the trial and error method and they prefer this. So as I consider that polynomial again, the 6x squared minus the 13x and the plus 5, the method that many of you have done either freshman year or in advanced algebra is to take the product of your first coefficient and your constant term, and that gives us a positive 30. All right. And then you break down that into factors so that they combine to give you the middle term. So our middle term is a minus 13x. So we're considering factors of 30, of a positive 30 that make a negative 13. And that would be a negative 3 times a negative 10. All right. Those factors add to make a negative 13, and we do what we call splitting the middle term in terms of the negative 3 and the negative 10. So we rewrite the polynomial 6x squared minus 3x minus 10x plus 5. And as you notice, we haven't really changed the polynomial. This is still the same polynomial if we were to add those middle terms together. But what we've now done is put it into a form where we can group and factor. So if we group the first two terms together and the second two terms together, each of those two pairs of numbers have a common factor. Here we can take out a 3x from each one of them, and that leaves a 2x minus 1. The second pair, when my lead term starts with a negative, I'm going to be dividing out a negative from there. So from my second part here, I'm going to be taking out a negative 5 from each. As I divide out from the negative 10x, that gives me a 2x. And as I divide a positive 5 by a negative 5, that leaves a negative 1. So just kind of look back and make sure you do have a sign here and that your product as you remultiply does give you those two terms. Now, as we look back at our greatest common factoring in the first part, we do see a common factor there. And we've got to take that factor out, 2x minus 1, and that's being divided out now, so that's gone. And then you have to write the factor that remains, which is the 3x and the minus 5. This is the part that a lot of people forget to do. If you don't have your final answer with one parenthesis next to another parenthesis, you don't have it in a factored form. Right here is where some people leave it. They don't do that last step, so they're having that negative sign or that positive sign in between. Your final answer has to have parenthesis next to parenthesis, otherwise you do not have a product. The fourth form of the factoring that we're showing here is what we call a perfect square trinomial. We've got a perfect square trinomial, possibly, if your first term and your last term are perfect squares. Not every trinomial that has perfect squares in the first term or the last term are perfect square trinomials. So we just try to work them out. The pattern is to rewrite your product where each of your factors has a square root to those first. So number 8, we'll come back here and we'll give it a shot. We'll see if we can make the two factors where they're the same, and we're trying out the square root of the first term, which would be 5w times 5w. Our sign patterns, since the last sign is positive and the middle sign is positive, the sign patterns would be plus. And then we're putting in the square root of the last term, which is 16, which is a 4 times a 4. All right, now we recheck the product and see if it works. There is the 25w squared. Here we have a positive 20w and another positive 20w, and definitely they make the 40w that's in the middle, and the last term times the last term is 16. So the pattern works, and as we rewrite our answer, we can leave it like that, or we can rewrite the 5w plus 4 and put the square in there. Right? The pattern that we show over here is basically letting you see that that middle term is simply twice the product of your square roots. So if I had the two square roots of 25w squared and 16, what product is 20w, and if I double it, I do get the 40w. Now as we look at the second one over here, this is just to let you know that just because you have those n numbers as perfect squares doesn't mean it's going to automatically factor as a different square trinomial. For example, if we come back here and try to write the polynomial as 3x and times a 3x, the signs this time are definitely going to change. Even though that last sign's positive, the middle sign is negative. So the correct sign we're putting in here is going to be two negative signs. And if we were to try to put in the square root of 4 as the other factors, when we check, we're going to see that that doesn't work. So as we come back and retry the factoring, the middle product is a negative 6x, as is the outside product is a negative 15. So now we don't have it done factoring correct. So we come back and we have to reconsider our combinations of what we could try. So that guy doesn't work. That guy doesn't work, and we'll give it another shot and try some different factors. All right, let's leave the 3x in there. We definitely need the negative signs. Put the 3x in here. And as we consider other factors of the 4, we could try a 4 and a 1. So if I come back here and I try a 4 in here, and I try a 1 in here, signs still have to be negative. Now I can come back and try that combination. Here you're getting a minus 12x and a minus 3x, and that does give you the negative 15x. So there we have the right combination for our factoring. And of course, if you want to, you could go back and do the split the middle term method that we saw back in the last section as well. The last section that we're seeing here is sum and difference of cubes. So there is a pattern for factoring here for you to kind of watch and pay attention to. And then the next thing is to recognize when you do have this particular type of form of factoring. So what you see here is that you've got either two perfect cubes added or two perfect cubes subtracting. Right? And as you look at our choices of the two down here, certainly there's just two terms there. One's subtracting, one's adding. The factoring pattern you want to see is that there's going to be a binomial times a trinomial. Both of those patterns show a binomial times a trinomial. Right? The first part of it, the binomial, is simply going to be the cube roots of the two numbers that you're either adding or subtracting. Right? So if you're doing a sum of two cubes, your binomial factor is adding those two cube roots. If you're doing a difference of two perfect cubes, the first factor is difference. Right? The second factor kind of follows from the first. Right? Whatever your cube root was here, you're going to square it for your first term. And whatever your cube root was for your second term, the very last part of that trinomial factor is going to square it. Both of the factoring patterns have a plus at the end. Right? The middle part is simply product of those two cube roots. And the sign patterns simply change. So if I had a sum of cubes, I have a pattern of a plus b, and then my middle term in here is a minus. If I have a difference of cubes, then my middle term is a plus. Right? So as we come and we look at the two, we want to basically at least be aware of the fact we've got perfect cubes. 8 is a perfect cube, cube root of 8 is 2, and the number 1 is a perfect cube. So this binomial can rewrite as 2x cubed. I've got the cube root of 8x to the third in there, and there's a difference of 1 cubed. So I've rewritten it in the form of the pattern that you see right here. All right? Now I can break it down into the binomial factor and the trinomial factor. So I go back and I rewrite that first factor as 2x minus 1. The second factor is going to be the trinomial factor, and now I have to take that first term and I have to square it, 4x squared. In the middle, the sign's going to change. I have a negative sign here, so now my sign is going to change to a positive and for the middle term. And then I continue with the product of my a times my b, 1 times 2x. I have a 2x in there. My last term is going to have a positive, and I come back to the second perfect cube that I had here, and I square it. 1 squared is 1. And now I've got my binomial factor times my trinomial factor. Alright, last one. The first thing I do is rewrite my sum of cubes as their cube roots. So the 125 can rewrite as 5x squared cubed. And the second part I can rewrite as 4b to the third power. And that way I can recognize my pattern as my 2 cube roots, and there's my sum. So then as I come back and I write my 2 factors, come down a little bit to more some room here, this will be your 5x squared and plus 4, and then you use those to base your trinomial factor. You want to come back here now, you want to square that first term, so that's going to be 25x to the 4th. And we have to come back here, we have to change the sign, and we have to multiply these 2 terms. So we change the sign to a negative, we multiply the 5x squared times the 4, and we have a 20x squared. And finally the last term is positive, and we're going to square that second perfect cube, and that gives you a plus 16. Right. And then you are finished. You've got your 2 cube roots here as your binomial factor. You've squared the first perfect cube. You've multiplied the product of those individual perfect cubes there, and you've squared the second perfect cube, and you've got your trinomial factor. All right, and you are done now with your first day of factoring notes, and tomorrow you'll be moving on to your day 5 assignment.